Hello again. This time we're looking at a system of three equations in three unknowns. I'll leave you to read the quote by or from Paul Anderson, but these sort of problems made me think of that quote. Hopefully we'll go about this the right way and not make it more complicated. The idea of this is not to solve the whole problem, which would take too long for my little video clip, but to just explain the technique you'd use to get started. I'm going to use the process of elimination because that's my favourite, and essentially at the start you're looking at just the coefficients of each of the columns. Actually not even particularly worried about the signs at this stage. I wouldn't actually write this out when I was doing the problem, but this is what I'd be thinking. Now, looking down, well, first of all, if you've got a 1 anywhere, and we've got one here, that is going to be really useful, because if you're going to use the process of elimination, you want to multiply an equation by a number which will make either the x, y or z coefficient match up with one of the other equations. Now, because I've got a 1 here, it's easy to multiply it by something that will make it match the 2 here and match the 7 here. So this is the technique I'm going to use. It's actually different to the approach I used in the written solutions that are on LMS, but you'll see it'll lead to exactly the same solution. So what I'm going to do now is set up an equation 4. I'm going to be using equation 3. Let's multiply it by 7 first, so the y coefficient will match up with equation 1. So 4 is going to equal equation 3 multiplied by 7. That should be 14x minus 7y plus 21z equals 28. Now, it's very important in these problems. You make a mistake at the first step and then everything else is going to be wrong after that. So just check back that you have actually done what you're intending to do. So multiply by 7, by 7, by 7, by 7. Yep, I'm pretty sure that's all correct. And I'm going to set up the other equation I'm going to use in my elimination before I start actually doing the eliminating. I now want to match the y coefficients, force equation 3 to match the y coefficient of 2 in equation 2, so I'm going to multiply it by 2. Not worrying about the signs at this stage, I just want the numbers to match. So 3 times 2 will just give me 4x minus 2y plus 6z equals 8. And again, just step back and do a quick double check in your head that you've done it right. Looks good to me. Now, because I've got 7y, 7y, 2y, 2y, and these two equations are just scaled up versions of equation 3. So I'm going to combine them with 1 and 2 and get rid of the y unknown in two different ways. So let's start with equation 6 is equal to equation 1, and I'm going to have to subtract equation 4. So that negative 7 subtract negative 7 will be negative 7 plus 7, the y's will disappear. Okay, so 1 take 4 is 5, take 14, negative 9x. The 7 y's are going to cancel each other out, as we've already decided. 4z take 21z is negative 17z, and 2 take 28 is going to be negative 26. Don't like all these negatives, so actually as the next step I could actually just put positives there, but I'm going to make equation 7 equal 6 times by negative 1 just to make it clear what I've done. So I'll get 9x plus 17z equals 26. Now, notice I've left a gap for the y column. I still want my z column and my x column to line up. Again, it's just a way of setting it out neatly so you don't make a mistake. Equation 8, I'm going to go back and use equation 5 now to eliminate y from equation 2. So it's going to be equation 2, and in this case I just need to add equation 5 because 2 plus negative 2 will be 0y. So equation 2 plus equation 5 is going to be 3x plus 4x is 7x, and negative 2z plus 6z is going to be plus 4z, and 3 plus 8 is going to be 11. Not quite as neat as I would have liked or hoped for, because the numbers are a little bit bigger than I would have liked, but hopefully there's no mistakes. Maybe double check that equation 8 is 2 plus 5, 3 plus 4 is 7, negative 2 plus 6 is plus 4, 3 plus 8 is 11. This might seem like wasted time, but like I said before, you make one mistake and you'll spend ages working your way through and come up with the wrong solution. So we're happy, and essentially I could stop here, but I've reduced the original set of 3 equations in 3 unknowns, change my colour here, into a set of 2 equations in 2 unknowns which you should be able to solve.